Hey, this is Mr. Hendrickson, and this is the Rocket Lab Part 1 of Vertical Launch Prelab. The purpose of this prelab is to get you primed and prepped so that you can take your rockets out, fire them successfully and safely, and eventually find out with what velocity do they launch and how high do they eventually go. Before you go outside, you need to make sure your team has all of the items listed here, including 2 stopwatches, a rocket body, rocket base, an air pump, and at least 2 calculators. You'll probably need to bring a folder and something to write with as well so you can get all your work done outside. In order to successfully complete the lab, there's some things we do need to know ahead of time. Fortunately, you've had plenty of experience with all of these over the course of the last few weeks completing problems as a class. So what you need to understand is that we're going to take this rocket and we're going to fire that rocket straight up in the air. As that rocket goes up in the air, we need to determine how fast it's going at the very, very top. Well, think about any object that you throw straight up. It tends to go up, 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 gradually slowing down until it stops and comes back, accelerating towards the ground. So the question is, how fast is that object moving at the very top? You should go ahead and make sure you fill that in for number 1. In the second part of the prelab, the question is, what is the acceleration at the very top of its path? You need to be extremely careful here. We know that this rocket launch is occurring on Earth. We also know that the acceleration of gravity never stops. The question is, what is the sign of this acceleration? Again, you'll want to refer back to a number of problems that we've done in the past, including the yardapult problem, the soccer kick problem, the baseball problem, or any other problem where we've got an object moving vertically through the air. Please make sure you label it with the correct units and the correct sign. Number 3 asks us to find the amount of time that it takes to get to the very top of the projectile's path, only from launch to the top. Now, your team is going to have 2 stopwatches to time the flight. The question is, should you take your stopwatch and time it from the launch to the very top, or is there a better way to do it? You, looking up from the ground very high up into the air at a rocket, you might have a very difficult time determining when it does exactly reach the top. So what's another way you could approach this to figure out how long it does in fact take to get to the very top? Think about it and write down that procedure in your prelab. Then, for number 4, once you have your time, your acceleration, and your final velocity, you're going to need to organize those parts, those variables, into an equation. Refer back into your notes at a number of the different projectile problems we've done in the past, and please find that equation that involves initial and final velocities, acceleration, and time. Make sure you write that equation in for number 4. And then finally in number 5, our job, the last piece of this lab, is to find the total distance, or not total distance, but rather the peak distance our rocket reaches above the ground. So take a look back into your notes and in your labs, and take a look at what formulas we've used in the past to determine distance in the y direction. You'll probably want to use the same formula here. Once you've found that formula, make sure you put it in your prelab and you're almost ready to fire your rocket. Now that you're ready to go ahead and fire your rocket, you need to take a look at the pieces of the rocket. There's the body, the nose cone, and the cap. You need to make sure the cap is placed on securely over the top of the launcher. Once in place, slide the body over the cap, press it down, slide the nose cone over the body. The next thing you need to do is make sure that the pump is clamped onto the base. Slide the pump over, pull the clamp back, and you're ready to go. Once you're ready to fire, you'll want to step up to the pump, make sure everybody else in your group is a reasonable distance away. Go ahead and pump a couple times. If you hear any air coming out, you'll want to check the pump to make sure that it is sealed up and no air is escaping. Take it off, place it back on, and create a better seal. Once sealed up, you're ready to go. Pump with your head out of the way so you don't get hit with the rocket, and watch the rocket go. Keep an eye on it as it's in the air. Make sure everybody else nearby knows it's going up. Go ahead and track it down and make sure all the pieces are there. Body, nose cone, and caps. You'll notice the cap will be jammed in the actual body. Press it out so you can place it back over the rocket launcher. As always, keep safety in mind throughout the whole process. If you have any questions, please make sure you read the lab. Hopefully, as you've watched this video, you've gone in and completed the Prelab web assign. Please make sure you do so now if you haven't done so already. Good luck!